Make sure that you're getting these right. And if you're getting them wrong, I want you to ask me now, because this is what you're going to be expected to know how to do on the final exam. So here's number 5. Check and see how you did. If you got it right, awesome. Now remember, there are only 33 questions on this final. Now that might seem like that's really easy, but get one wrong, you're already dropping pretty low. Okay, so let's see, 32 divided by 33. You get one wrong, you're at 96 already. You already dropped 4%. Okay, so I understand that, like, the problems, like, yes, it's only 33. That's super exciting. But that just means that there's less that you can get wrong to get a good grade. So that's why you need to take an hour and 15 minutes that you get. Don't just turn it in, done. Awesome, done 10 minutes. Because you could be. But take your time and check your answers. Okay, so do you have questions on number 5? Bottom to top, yes. The range is always bottom, and that's why the negative infinity is down here at the top. Some of you put 2 to infinity because you remember doing interval of decrease with me earlier that day. If I asked you for decrease, it would be 1 to infinity, but I asked you for the range, which is negative infinity to 2. Okay, the next one that we did then was 12. Okay, if you look at 12, I crossed one out. And if you notice, I crossed off minimum because that's why I chose not to use that one. So already I have a 50-50 shot. Remember, on the final exam, it's just like this. You only have 3 options. So really now you're down to 2. Because I know it's a max. Now, look at how I did it. I labeled that my x value is 1 and my y value is 2. Well, look, it literally says x equals 1. I know it's written weird. You're used to just writing it in order, but the max value is 2. Your max values are always going to be your y's. Okay. Then we did 14, which was here. I think you guys did okay with this one. Again, I crossed off C because minimum. That's not a minimum, that's a max. So you should have already done a 50-50 shot. You have questions on 14. Okay, moving on to 15 then. Now, this is the one where a lot of people get wrong. Interval of decrease. Intervals mean your x values only. This is probably one of the most common errors that we have on the exam. X value. So right away, I know it's going to be 1. So I could have crossed off A right away. Because I'm not looking at Y, I'm looking at X. Then I go left to right. So your interval of decrease is left to right, just like domain is. When I go left to right, I start at 1, and I go on forever to 2. Like you're talking about the domain. Where is the function decreasing? Oh, it's decreasing from 1 and on. Okay, it looks like it's going, a lot of people will put negative infinity, but it's not going, we're not talking about where it's going. We're not talking about the end behavior. We're talking about the x values. Okay, then we're on 17. Okay, identify the number and type. Look, I labeled them. If you can actually put them on paper, they're real. I can count them in purple, 1 and 2. So I have 2 reals. That's it. The only time it's imaginary is if it doesn't cross at all. Okay, then I had 25. So flip with me. Check your answers, please. 25 was that imaginary one. Look, I even highlighted it. It does not cross for A at all, and that's why it's imaginary. Hopefully that's one of the easier ones on your exam. Think imaginary does not exist. They do not cross the x-axis. Okay, 26. People get this wrong because they forget that they have to change the signs. Because our original formula says minus R1 and minus R2. So if I start off with R1 being -3, it must turn positive. If I start with R2 being +2, it must become negative. B I could cancel right away because of this negative. That negative out in front means down, it's going up. Try to be a good test taker and at least get it down. Most of these questions could be eliminated to at least a 50-50 shot. Okay, 27. so many ways you can do this. I just plugged it into my calculator into your head. Once you get to the x value, you'll notice you really don't have to go any further. That was the only option with the x value being -1. Or you go in your graphing calculator, plug it in, and you find the vertex. Yes, but yeah, well, because majority of the time, if you look here, the only option that has -1 is. Okay, then 34. This is probably one of the tougher ones of the whole final exam. Okay. If you notice there was no 33, I forgot to change the number. There's only 33 questions on the final exam. That number is supposed to be 33. I took out 33 from last year. Now, something to remember, I told you guys to look at your answers. Here I'm looking for the x-intercepts. Here I'm looking for the vertex. That's what you were looking for. That's what we talked about in our notes yesterday or in our review together. So it's going to be either or. Well, again, opposite signs. So it must be number 2 and the vertex. You plug it into the formula, it changes the sign of the x value. So we'll see. If questions on that group. Is there anything you would like me to re-explain before we move on to chapter 5? Just really quick. So it should not take very long in class today. But is there anything that maybe really stumped you on this packet you got that you would like me to go over? Because this is supposed to be your studying time right now. Absolutely, yes. Yeah, so right now, if you get stuck on 34, what Jake just said is completely 100% correct. You could put in every single one of these into your calculator because you will have that much time on the final and see which ones match. Absolutely correct. That's a wonderful tool. Okay, now get out your green packet, please. As long as you can. Oh my God, you're so sweet. Thank you. My gosh, you're the best. All right, so we're going to chapter 5 right here. Here we go. This one should look familiar. This one should look familiar because it was the one from your midterm exam. The exact one. Because a lot of you got it wrong. Yeah. It's not B. It's C, but good try. So let me explain why it's C. Let me explain the question first. It says, choose the graph of the function below that does not have a domain of negative to positive. Now look, remember what I told you guys to do to help you with domain and range? Negative infinity to positive, negative infinity to positive, negative infinity to positive. A and B are forever going left and forever going right. This one for C, it's stopping right here. That's restricting my domain. Stops or starts technically at that line that I just drew and goes on, yes. Yes. Okay, questions on that one? Hopefully that becomes an easy one for you to see if something is restricted or not. Please don't whistle. Okay, look, now we're looking at this. Well, hopefully you're bored because you know it. Given the graph, identifying the domain. So now we kind of already talked about that it's not going to have a negative to positive infinity domain. So we're going left to right because that's what domain is. Domain is left to right. And I told you I'm going to write a lot of notes during these because this is your study session with me. So you don't have to do it at home. And you can study about all the other stuff later. Let me explain it first. So going left to right, I like to put in my infinity signs. I'm not going to put it on the top and bottom because domain is not top bottom, it's left to right. So you're like, oh, I'm looking, I start left and I'm going to come over here, I'm going. Where do I start at what number? -2 right here in yellow. So from -2 to where? Where's it going? To the right. Good, to positive infinity. So take a look. I am starting here at x equals -2. and I'm going to positive infinity because it's left to right. Am I including negative 2? Is there a hole or anything? Can I include negative 2? Yeah, so I have to put a bracket. Because remember last chapter we talked about these things called holes or removable discontinuities. So I have to be aware of how I write this out. Okay, next one here. Sketch a graph. So this is just practice of you understanding what even and odd meant again. So sketch a graph with an odd degree. Let's talk about that before we move on. Odd degree functions. Are they the same arrows going up and down, or are they opposite arrows? Opposite. So I'm going to put that down just so that you can study that opposite. It's technically called end behavior. But if you forget what end behavior is, you can kind of just put it like in parentheses. It just means arrows. So it has opposite arrows or end behaviors. I just don't want you getting used to saying arrows because that's not technically the term. And then a negative leading coefficient. Okay, that one's a little bit tougher when it comes to odd degrees. Does that mean I'm going to be trending up, or does that mean I'm going to be trending down? Yes, which means I'm trending down. So technically the right words is trending down. That just means you're decreasing at the end. Decreasing. So I'm not asking you to be very technical. There is nothing to graph on the graphing calculator. As long as it looks like it's trending down, I'm okay. And the opposite end behaviors. So here we go. The opposite arrows are there. Check. And it looks like it's ending down. It is ending down. Question on that one? It does not have to go through 0. Okay. You could have drawn anything. You could have been like over here. As long as you have it looking like it's going down, the arrows are opposite. Okay. Now we're just going to talk about every situation so that if I ask you any of these questions, you know. This one, I believe I changed it for yours, hopefully. Does yours say positive for 4? Okay, good. I just didn't change mine on here. First one, though, odd degree with a negative leading coefficient. We just talked about that. I'm going to kind of just draw that off to the side because we just did one like that. Negative. It's asking, determine if we have an absolute or relative max or min. Remember what the difference is. All the above would have what? Absolute or relative? Not all of them can have absolute. Does anyone remember which ones can't have absolute values? Odds. Let me explain it. So, take a look. I'm going to write a note actually first. Only even degrees will have absolute values. So I'm going to put that down just so that you have that to look off of, because that's important for one of the questions on your final. Here's why. Do you see if the arrows go opposite directions? There's nowhere you can tell me that's absolutely the highest point in this graph. Because technically here in blue, I'm like, hey, this right here is the absolute max. It's not though, because there's all of this function off to that, the left side that is higher. So for these two, for all odd degrees, you can have a relative max or min. You just cannot have an absolute. For both of these, you can have a relative, but you can't have absolute. So I'm just writing that down so that you know that no matter what, odd degrees cannot have absolute values. I'm going to draw this one out because it'd be trending. It's kind of like a nice little area for you to sketch some stuff. Now, yours can definitely look different, right? It could look like this. Sorry. I don't want anyone getting sick for finals. Sorry. Even Even his same end behavior, it says negative leading coefficient. Does that mean they're going to be both up or both down? Negative means down, so it's going to look something like this. Can even functions have absolute? Yes, so we can have either of them. So I'm just going to put any, because it can have all of them. It can have an absolute max. It can have, oh, no, it can't. Erase that. Yes, it has an absolute max. I'm sorry, I apologize. Because look, for number 3, the one I drew off to the side, this in green, that piece, there's no point higher than that green spot right there. That means you have an absolute max. Okay, now the opposite here is going to be going up because it's positive. So I can have an absolute what? Min. The biggest thing that you need to walk away with is even degrees are the same direction. So that means that there will be an absolute max or min. Yep. And I'm going to go like this. Both of these can have relatives. It really doesn't matter. You don't really need to know that information, but both of them could have relative maximum. And here's what I mean by that. You don't have to draw this in, but technically, if I drew something like this guy has a relative max. But I'm not really worried about that part. I'm more worried that you were able to tell me that an even degree is the only one that can have absolute. A lot of people got that wrong on the midterm. This is why we do the midterm, so I can see where you are when we do this review. Okay, next part. Given the function f of x equals x cubed, reflect over the x-axis, that's one piece. Then we're going to translate 2 units right, and then we're going to go 4 units up. You guys were so good at transformations. If you have your that bright green sheet in the very beginning that we did, I put it in bright green so that you were able to find it easily, because almost every single chapter we do in Math 3 has transformations. You were really good at this. Give me 1 second. So the original formula for transformations is you have g of x equals f of something, x minus h plus k. Where, again, this is just for you to study, the number out in front, which we call a, that's going to tell us, sorry, I put it in the wrong spot, my brain's off from being sick. Hopefully you're using a pencil. The a out in front tells us if we are going to be reflecting or compressing, stretching. That's what that number out in front tells us. Does anyone remember what the h tells us? Are we going to be going left, right, up, down? Which one? Which pair? Good, left and right. So this piece right here tells us if we are moving left or right. This piece right here tells us if we're moving up or down. So just to kind of go over things. You obviously, I feel like a lot of you knew that if you were to see it, but I wanted to write them out for you. So if we're talking about reflecting over the x-axis, now let's actually do the problem. G of x equals, which letter, A, H, or K, am I going to put a negative for? A, very good. And we're just filling it in as I go. I'm going to use black just to show you what I'm just filling in right now. If I'm going 2 units right, is that going to be the H or the K? H, good. So I'm going to have X minus my right, I'm going right 2. Now if I'm going 4 units up, I'm just going to have that plus 4 on the outside. What am I saying? X cubed, you're correct. But if I write it in this notation, I don't need that. That's fine, but then the F needs to come out. Okay, so either one's fine. I would accept either one. Just know what your question's asking on the exam. Yeah, so he was asking, could I write this? And he's absolutely correct. If you did this, that's fine too. Because I'm in Q, but in this situation, it doesn't matter. We could have wrote it either way. Good question. All right, we're almost there. This is just asking, tell me the transformations. Well, guess what? We just went over all of them. So let's highlight each piece that's different. The 1/2. What does the 1/2 tell me? Good. Compress by 1/2. What does this next piece? Because everything that's different, if you look, alpha of x is x to the 4th. Well, the 1/2 is different. The 3 wasn't there before. The -5 wasn't there. All mean something. So the 3, what does the 3 mean? Yeah, very good. Left 3. What does this -5 on the outside tell me? Very good. Down 5. You did a really nice job with that one. Be careful on the final, you won't really have this choice. But in general, you're not going down -5 because you can't move negative. You can't move negative distance. It doesn't exist. You're still moving distance, you're just moving in a different direction. Okay? All right, we're almost there. This is the one that a couple people struggled with. For this situation, you will be given the formula on the exam, so let me give it to you. Yeah, well, feeling's wrong because I'm never gone. Okay, so why would I miss final exam week with you guys? I want you to be ready. I don't care if I have to suffer. I'm spraying. You're not going to get sick from me. Okay, here we go. Average rate of change is y2 minus y1 all over x2 minus x1. That will be given to you. It's also in your interactive notebook already. Now, get your 2 different color highlighters out because this is where it's important. It is. By x1, I'm going to do one color. I'm actually going to put in x1. See it. Then I have x2 in a different color because I'm trying to figure out what is the rate of change between those 2 x values. Remember, x values are where it's located. So what I'm going to do in green is highlight the point that goes with it. So right here, 1.962. That's my x1. So what's my y1 then? In this problem, what's the y1? Thank you, 132. They're an ordered pair. They go together. So now on this next part, same thing. I'm going to highlight my 5. Well, that's my x2. What's my y2? Thank you, 0. You see how they go together? They're a pair. So now we can plug in our whole entire formula. Now it's easy. So let's just plug it in as I see it. Now I'm going to keep everything in black. That should stay the same because I'm not really doing anything with it. And I plug in what I know. Y2, you guys told me was 0. Putting that in. Y1, you told me was 132.038. So 132.038. Sorry, I'm running out of room. My parentheses there. Let me write that for you. Okay. What's my x2? 5. What is my x1? Good. 1.962. Take out your calculator and plug that in. Because now you have everything you need. See, it's not that hard. You just need to take your time. What do you get? It should be a decimal, yeah. Yeah, you might need to check this. We'll check that. -43 what? Yes. So let me explain why I knew yours For something for a prize. Actually, you know what? For an extra credit point. Well, you have to raise your hands. You don't shout at me, please. Why did I know angels is not right away? Well, obviously that's kind of like what about this tells me something. Line, go ahead. But why did I know when he gave me the answer it was wrong? Like it could have been that answer, but there was something about it. So it's going down, which means it's negative. Yes, thank you. I'll put that in. So right here in yellow. So what I'm just saying, it's a really good example because he shot out 0.05 or point something, but he didn't say negative in front. You should know it is negative because it goes down. That's a great way to cross off answers on your final exam. Because this is going down, you should have known it was going to be a negative number. Please be aware of that. Okay? If you got positive in your calculator, you put something else in wrong. Be a good test taker and know what it means and know what you're doing. So, given the graph, which values of the function are increasing? So I'm going to take a different color highlighter, and I'm going to be increasing from this point on in orange. I'm increasing, and I'm increasing from this point all the way to here. This is when you want to put in your negative and positive infinity to help you out. Here we go. Left to right. So increase and decrease is always going to be left to right. I'm starting at negative infinity. Where do I stop increasing at? Not the y value, the x value. Good. Okay. So look in orange, negative infinity, and I stop at my x value. Maybe I'll put a little line here for the in orange, the same color. This is where I'm stopping. I'm not increasing anymore from this point. I start to decrease. Now let's go to the next piece. Where am I starting now? Good. I'm starting at 6.371 and I go on forever to infinity. Oops, that wasn't supposed to be closed. Good job. Almost done. We're almost there. We got one more little piece and we're done. We can work on that multiple choice, which is not that many. Describe the end behavior. End behavior represents the arrows. Where are the arrows going? Okay, so here we go. I'm X. You do not have to write this down because I'm going to be scribbling. I don't want you to scribble all over your paper. I am X right now in purple, and I'm walking towards negative infinity. Here I go. I'm going. But where is the function going as I go towards there? Negative infinity. Very good. So don't write all that scribbles. I'm just trying to show you visually why. So here in blue, as X is going to positive, I'm going there, I'm walking towards it. Where is the function going in that direction? Positive infinity, very good. So end behavior has to do with where the arrows are going. Interval increase and decrease is telling me where is it decreasing? Oop, we do have one more, never mind. Ooh, this one you're gonna have to know how to do a couple times. We did this already in the last chapter. Whenever you're trying to write a function and you're only given a graph, the only way to do that is to use that intercept form, which you guys are starting to get a little bit better at. X minus one of your roots, X minus another one, and X minus another one, because we have 3 in the situation. What is my first root in purple? -1. What is my second root in pink? And what is my third root in green? So all you're doing is you're plugging each one of these in to the function. On a multiple choice exam, it'll be a lot easier to see that the signs just change. So look, when I plug in the purple and that -1, what happens to the sign? For the 1? Yeah, it changes to a positive here. Look, a negative 1, when you plug it into a negative number, it just turns it to positive. So then in pink, am I going to have x minus or x plus 1? Good. And what about the 3? Good. Okay, you're getting better at that. Okay, so the remainder of the time, you have